Okay. So, am I audible? You all can unmute yourself and respond also. Uh, like I am not constantly watching at the chat. So just unmute yourself and respond. Am I audible? Anyone? Okay. Okay. So first of all, good afternoon, everyone. I'm Ankit Kriti, and I will be your TA for today's session. I also have Ritik Elikar with us. He will be clarifying your doubts regarding the previous sessions. So, so far we have gone through interfacing of many sensors and displays. Okay. Do you feel that any of them are hard in like difficult to for you to understand? If yes, then just um, unmute yourself and respond that what did you feel uh, like difficult about that particular sensor or that particular display or microcontroller. So you all can respond by unmuting yourself. Please do not respond in chat box. uh, I want you to interact. So just writing in chat box is only a one way communication, right? You should be able to talk. Okay. So just uh, tell me if you have faced any issue with the previous sessions. Do you have any doubt regarding any of the previous sessions? No doubts? Were you able to understand the previous those previous sessions completely? Okay, I think I should pick one by one and ask them individually. Okay, so okay, Likhita, can you respond? Likhita, do you have any doubt? Shiva, your camera is on. Okay, Likita, can you respond? Do you have any doubt in previous session? Did you attend all those previous sessions? Just feel free to interact. Okay, we are also students here who are teaching. So, like if you say anything wrong, if you do any mistake, we are not here to scold you, right? Just clarify your doubts. If you have any doubts, just tell us. Shiva, your camera is on. I think you could rejoin. Okay. Siddhanta Poo said that we completely understood the previous session. Okay, is it only for you or everyone else also? Do like is everything clear? Like you have no doubt whatsoever? Okay, let me ask you some questions then. Uh, can you tell me what are the controllers that we have talked about in the previous sessions? Just unmute and speak. Come on, guys. Just there's nothing wrong in speaking, right? You can unmute and respond. Typing in chat box will take a lot of time. So just unmute yourself and speak. What are the microcontrollers that we talked about in the previous sessions? Like if you understood completely, you should be able to like respond. Shidantapu, can you tell me what are the microcontrollers that we talked about? See, like not clarifying doubts, not responding will be not your will not be in your favor. Okay, so at this time you won't be able to if you won't respond to my questions, you won't be able to understand the topics clearly. Okay, you have to showcase this as your like one of the skills. So you have learned embedded programming. You have learned to design an embedded system. So for this, you need a better understanding of the subject, right? So just respond to whatever I say. I just asked that what are the microcontrollers uh, we have studied in the previous session. So can anyone just unmute themselves and respond to this? Arjun Kumar, could you please just answer my question? Okay. this online mode of teaching, is it fine for you? Like, are you able to understand I'm sorry, Tinkercad? Like, are you comfortable with Tinkercad now? Uh, are you able to interface some sensors, uh, or are you able to like interface some display units, or are you able to interface a sensor in a display unit to display the values? So, are you able to do that? Guys, please respond. Yes, it is a microcontroller. Arduino Uno is a microcontroller on which we are doing uh, programming till now. So, what are the display units that we have studied so far? Did we ever see any display unit? Res- Respond by just replying, like unmuting yourself. Okay, Sri, can you just unmute yourself and respond? It will be better for me, to get your answers. I'm not constantly looking at the chat.
Yes, sir. Can you hear me, sir?
Yeah, you're audible. So,
LED is the display
okay,
we have
LED.
used.
So, were there some other display units? What were the names of those display units? There was a particular name for a display unit, right? That's one session I took on the display unit itself. So, do you recall that? Have you heard of a seven segment display?
Yes, sir. So you have there, like, yeah, sir.
Okay, so seven segment display is a display unit. Why? Because it displays a particular value that we want to show as output. Okay, it is an output unit. You can say that. So, see, if you won't clarify right now, Sri wrote that LED. LED is a display unit that we studied. Yes, correct. It is a display unit, but do you didn't know the actual name for it? So it was a seven segment display. Okay. So if you respond, you can just cope up with the whatever you have. You can get a revision of the previous session. If you have any doubt, you can respond by unmuting yourself. Okay, there is no one to hang you for unmuting yourself. Okay, you can just unmute yourself and respond. If you have any queries, unmute yourself and ask the question. Okay, so tell me one thing. Are you this online mode? In this online mode, we are having simulations only. Okay, so is it fruitful for you? Are you learning something, or are you
Yes,
thinking that?
sir.
Yeah.
Yes, sir. We are learning something. Like, we are getting it, but I think we need some time to process the like. We need to revise the topics, I guess.
Okay, so what are you what are the issues that you are facing? this is not a history subject, and you
Yeah.
don't need to like mug up. Just tell me what are the like bit so small issues must be there. Okay, like in understanding or in implementing. So can you tell me what are the issues that you are facing?
Yeah, sir. We are CSC students and we have zero knowledge in EC subject and we don't know about the hardware and things. Most of us. So that's the main issue we are facing here. That's it. And we are trying to find like whenever you give Arduino board, at first we found difficulty in finding the ground and other places. Like after that we got them. So that's the
Oh,
main issue, sir. We don't know the parts and components of things.
okay. So tell me one thing. The previous session that I think Ritik took about the history of IoT or explaining the what is IoT. So did you understand that?
Yes, sir.
So did you completely get what is IoT?
Yeah, sir, we got it. We even explained it with some examples. So
Okay. So you are saying that you are CSE student and you don't have good knowledge of what are the components so that are available in say Tinkercad. So are they similar or not, or what are they called? So that's what your issue is, right?
yes, sir. You're right.
Okay. So so far whatever we have done, we have like you have joined through digital mode, right? So you can always take screenshots. Okay. And I think we have explained about every component in every session itself. So we have also explained if I talk about my session, in the first session that I took about temperature sensor, I also explained that there are two or more types of temperature sensors available in the market. Okay, right. I am talking about temperature sensor because what we need to do is we need to move on with the temperature sensors and use that to integrate it with the whole system. So you need a microcontroller. So Arduino Uno is a microcontroller. We talked about it in my previous session. Okay, just a second.
Yes, sir. Another issue. Yes, sir.
Yeah. Can you repeat?
Yes, sir. The another issue is we can't find some components in Tinkercad, sir, like BMP280 board. We can't find it.
BME 280, no?
Yes, sir.
Yeah. Okay. So for that, in my session, I told that instead of BME 280, see, BME 280 is used to display temperature and humidity. Okay. And what we need right now is only one of those parameters. So even if we have the temperature, it will be good for us. So for that, a session was taken by me that showed the interfacing of temperature sensor, see TMP 36. Okay. So that is used just to detect the temperature. Okay. If you don't have BME 280, what is the alternative that you can have is you can use the temperature sensor for displaying the temperature. Right now, for just for understanding sake, we need only one parameter. After that, when we'll be shifting to a physical hardware, you can always go for multiple. BME 280 is also responsible for pressure. It is also responsible for showing like temperature and humidity data. So that can be done using the physical hardware. Okay. The tutorial, the experiment that we shared with you showed only a limited amount of sensors that are available actually on the Tinkercad environment. Tinkercad is basically just for understanding what is embedded systems. Okay, just getting a feel of it, or as how we can program. Suppose if you go to a suppose you need to use an LED. Okay, and you need a power supply to power the this your microcontroller. Okay, instead of actual laptop, connecting it to laptop. Okay, so if you use a higher powered this battery, it will damage your microcontroller, and it will also like damage affect the LED itself, right? Agreed. But if you try it on a, see, what you say, this Tinkercad or any simulation environment, you can omit these mistakes. Okay, you can learn on these simulation environments from the mistakes that you do, and you can avoid those mistakes in the actual project. So that's the purpose of this Tinkercad. It is not for a complete understanding. You won't find everything on the this Tinkercad platform, but it is just to give a gist of what is Arduino programming, how we can interface any sensor with microcontroller, how we can interface any display unit with microcontroller, how we can use a particular setup as a project. So suppose if I use a temperature sensor, a display unit, say a 7 segment display, a microcontroller, and a breadboard. So it will be a whole project, right? A temperature monitoring system, right? So that is the basic idea behind Tinkercad. Right now, what we feel is that you should move to physical hardware. So, I would suggest you all to ask your management, ask your college management whether they can provide you with these hardwares or not. Like if you can form groups, and for each groups the college can provide you a particular list of hardwares. We can also provide you with some list of components that are easily available in the market, and you can buy them. Your college can buy them and circulate it to you, one kit per group. Okay, in that way you all will be having this kit with you. If you are not in the college, if you are at different places, you can also buy those kits. So just ask your college management that can this be done. We are to we want to learn about embedded systems. Want to learn about IoT, because in the future IoT will have a very huge scope, because everything is going towards automation, right? You don't need to now you don't need to go to your door and see if who is on the other side. The whole thing is managed by automated sensors and cameras itself. So this is a very beautiful application of IoT, and it will even grow further in the long run. So try to convince your management or ask your management that whether we should what can be done with this. We want physical hardware, and we want to try it on physical hardware. It will be very very beneficial, as in physical hardware you will be able to do soldering. So we have provided a separate this experiment for soldering, where the soldering process is explained completely. You will be able to do connections, so you will be able to understand what is a positive and what is a negative terminal, and why you don't need to short both of them for a battery or for any power supply. So you will be learning from your mistakes. Okay, you will be learning from those practical applications. In our college also, we tried it on the actual hardware. We made some projects, then only we got this knowledge about the embedded system. This whole process is known as hands-on learning. Okay, so, or learning by doing. I see right now IIT Bombay is having a lab known as Yantra lab, and their motto is learning by doing. So they give projects, and you have to do those projects by searching on internet, by learning from the internet, and doing the connection by yourself, and then only you can get a command of that particular topic. Okay, so just ask your management and get the kits. We will be soon. We will be providing a list of necessary items. And can you tell me, like you are all present in your college, or you are doing this from your homes? Can anyone just
So some are from college and some are staying at home. Not everyone are there.
okay, so you all are at different places.
Yeah, so most.
Okay, so you are from you all are from which year?
We have just entered into our fourth year.
Okay, okay. Okay, fine then. What you can do is uh, like uh, those who are in the college, they can like try seek the help of your management, and see if anything can be done for a generalized solution can be developed for everyone, because those who are away from the college should also be able to learn, right? So in that way, just have a meeting with them, and then decide, and then you can always talk to us about this. Okay. So
Okay.
yeah. So the main doubt that you are having, that we are not getting the components, we are not getting these components on Tinkercad, will be sorted out with the physical hardware. Okay, you will also be getting hands-on experience, and at that time you will be liking those projects even more. Okay, so uh, do you have any doubts other than this, other than those components itself?
So I have a doubt related to something.
Like you are not clearly audible. Okay, only let's just okay. Think I couldn't. If I by mistake pronounce your name wrong, please pardon me. So Lasya Sri is
Yeah,
only responding. Can anyone uh, other than her respond to this? Do you have any doubts?
sir, actually I have a doubt, sir, regarding
Yeah, yeah.
subject.
Hmm.
Like today morning I have browsed through internet and read some articles about IoT, and there is something related to machine learning and IoT. Like
Hmm.
having machine learning in IoT, like I didn't get it, like how they use IoT in machine learning.
Okay.
Can you give any examples?
Yeah, yeah. So uh, I would give an example. So our professor, Dr. Sachin Chaudhary, used to take IoT lessons here. So he also have a very sweet example of Nest Hub. So do you have ever heard of this term Nest Hub? Nest, not a pigeon's nest or a bird's nest. No, it Nest Hub. Nest is a yeah. Nest is a company. So it was founded by these Apple engineers who left Apple, and they founded this company that made thermostats. So what thermostats do is they control the temperature of your of like any device, if of any see say what you say if in irons, iron, there is a thermostat which regulates the temperature for that iron. Okay, so how hot you want, how cold you want, how control the temperature in rooms too, right? Yeah, control the temperature in rooms too. So the basic example that we all have in our homes is iron. Iron has a thermostat that regulates the temperature. Whenever the temperature exceeds a particular range, so suppose we have set it to 45 degrees Celsius. Suppose it exceeds 45 degrees Celsius, it will cut off the supply, and then after a particular time it will again turn off the on the supply when it sees that the temperature has dropped a lot. Okay, so what happens in the foreign countries is that they're like in India, we are having all all the four major seasons, right? But in in America or in in northern or in the southern area, mainly in northern part, what happens is there is the environment is very cold, so you need a heater, or you need a whole room heating system or house heating system to run continuously throughout the day, right? But what happens is if you have a heater which has to be run at suppose which has to maintain the whole room's temperature at 26 degrees Celsius, which is a room temperature, 25-26 degrees Celsius. So at that temperature, what will happen is it will continue on running, and you have if the environment outside the house is a bit warm, the reading will immediately go towards like 30 degrees Celsius or so. Okay, and this we don't want. We don't want a sudden increase or sudden dip in the temperature, right? So for that, there is a solution that we have to manually adjust the thermostat to this temperature. Okay, we have to manually adjust whether this temperature is needed or not. Okay, you have to set it to a comfortable temperature. But what the Nest group did is they came up with a automatic IoT enabled temperature, this thermostat, where you set the temperature once and it will monitor your readings as how you are adjusting it throughout the day. Suppose in the day, suppose this is the January month, it is very cold outside, and I'm setting it to maintain 26 degrees Celsius. Okay, it knows that on January this month, that this day, the person has set this temperature. Okay, and it will what it will do is another day, on the 2nd of January, suppose, it will check if the outside conditions are similar to the previous conditions, and then it will set the temperature according to that. So it remembers what you have done. This cannot be possible just by like storing the temperature, current value in the temporary value, and then modifying it further. This has to be modified using machine learning models, okay, or using AI models, right? So suppose I have a data of this 1 year. See, 1 year I have adjusted it according to my needs. I have a data that on this day I have adjusted this thermostat to this temperature. Okay, on when the outside temperature was this, suppose X temperature was inside and Y temperature was outside. Okay, so this data can later be like used by the machine learning or AI model to predict that okay, suppose this is the outside temperature. Right now we are having uh, 13 degrees Celsius at outside. So right now, to maintain this 26 degrees Celsius, I need to pour more heat inside the room. Yes. So what? Here, what they did is they collected the data using the sensor. They controlled the thermostat, the heating system using the thermostat. So this is a IoT application. Okay. The third thing what did is they used models. See, machine learning or AI models, mainly AI model for this particular example, and they use that particular model to predict that what is the temperature, what will you be needing in this kind of environment out, which is outside. Okay, Even it also learned that, okay, I am leaving for job at 9, and I am coming home at suppose 5 and or 6. Okay, so it learned that, and it adjusted, before 1 hour, it started the this before 1 hour, in the evening, it started the heating system. And when I came inside my room, I found that, okay, the room is in a comfortable is having a comfortable this environment. Okay, it is uh, what do you say, a luxury for people who want to automate those uh, this manual tasks. Okay, one of them, actual examples that we did here is, we collected a data for these once I think I showed you water meter nodes. Okay, so we collected the data for those water meter nodes, and what we did is we ran a machine learning model to check if the model can predict the data. So suppose my meter runs for 5 hours, okay, and it shows that 5 kiloliter of water has flown today. So can it be able to tell that how much kiloliters of water will it be passing from the meter on for the next day? So in this way, we are using machine learning models for analyzing, even for analyzing data, and for predicting the outcomes as how it will be in the future. So this can also be useful in predictive maintenance of this pumps. Okay, we can have the data for we can see that the if the flow is dropping, even if the pump is running, pump or motor, water motor, I hope you understand water motor. Okay, so if it is running for a continuous time, and if you see that there is a sudden drop in the water outflow, then you can think that, okay, there must be something wrong with the pump, so it might be needing maintenance. Okay, so these all things can be done from machine learning. Okay, did you get my point, what I'm trying to explain about machine learning? Okay, I hope I'm clear with this, how we can integrate IoT and machine learning. It can always be used for analysis as well as for uh, predictive maintenance, for controlling of those IoT devices. So making making any IoT application is not a very big deal. Okay, you can always make some applications, make some projects related to IoT that can solve a common problem. Okay, but the thing is, after getting the data, you have to collect the data. Data is very important for us, because with that data, what we can do is we can further extend those projects, further improve those projects. Okay, and we can get valuable insights from that. And these insights are very beneficial in developing those projects even further, even to that extent, where you can get a chat gpt kind of a chatbot. So it must be a basic chatbot developed by any random guy. But later, with integration of AI model, it it began to develop, it began to learn. Right now what they are doing is they are collecting those insights, they are collecting your questions, whatever you are asking from them, they are collecting that, and they are training the models according to that. So what will happen is, have you seen a baby uh, like he doesn't know uh, how we are speaking English, or how we are speaking any language. Okay, but he learns how he learns to speak. He learns to speak by watching. Okay, he learns to speak by listening, as how we are doing a particular how we are pronouncing a particular word. He learns through that. So what is the data here? The data, whatever we are speaking, whatever we are producing, is the data. The model is the brain of that particular child. So the child's brain is like inside it is running the model on the data kind of thing. Like you can imagine, right? The brain is working on a set of data. It is understanding the data. Okay, uh, if someone shows me a flat circular disc kind of a structure, this I can call it as a plate. Okay, so the brain is understanding that. And after that, when the boy understand it that okay, this flat circular disc is a plate, he will start to respond to it whenever he sees a plate. Okay, this is a plate that I'm having on the table. So in that way, a computer should also learn. Okay, and it always depends upon the data. And IoT is the best possible technology to provide, like provide with a huge amount of data. Okay, so I hope this like these talks must be a bit what you say, over the top, but I hope that you will be a bit fascinated about AI, machine learning, and IoT in the future, right? Do you have any more doubts regarding this or regarding any of the other topics related to, say, IoT or whatever session that we had? You can always ask me. Okay, so moving on with today's session, I would be explaining you another display unit, which is known as LCD. So LCD stands for liquid crystal display. We have studied about LED, which stands for light emitting diode. So those are small LEDs in a 7 segment. I will be presenting my screen, just a minute. Screen. Okay, is the screen visible? You can unmute and respond because I'm not able to see the chat right now. Okay, please unmute and respond. Is the screen visible?
No, sir.
It is not visible. Like, can you see the screen now? Anyone, please respond. Can you see the screen, the presentation slide?
No, sir.
Okay,
It's visible now, sir.
okay, now is it visible?
Yes, sir. Yes, sir.
Okay, so in the previous, uh, it is visible, right?
Yes, sir.
So in the previous session, what we learned is we learned about 7 segment display. In like my previous, the previous session in which I taught, we learned about 7 segment display. So these segments were the LEDs, light emitting diodes. Okay, a diode, LED. You have seen a normal LED, right? So these are also some kind of LED, but like in the form of a dash kind of a structure, in a line kind of a structure. Okay, so these need to be individually turned on or off. Okay, depending upon the use, depending upon the whatever we need to display. Okay, so this is the basic functionality of an 7 segment display LED. Okay, but what we are studying today is a LCD display, liquid crystal display. What happens is it has a kind of liquid inside it, and depending upon the voltage that we provide, we don't need to go deep into this, the working, but I'm just explaining the gist of it, that whatever voltage we provide, it shows up, it forms a particular character for that. Okay, depending upon the voltage itself. Also, it has to like make it readable. There is a backlit, so there is a light behind the display that is illuminated, and that shows the numbers or the characters on the display clearly. Okay, so these are like more efficient than LEDs. So why is it so? Because in LEDs, what happens is it is always the all the LEDs are always in always on mode kind of thing. Okay, they you if you even you, if there is a black kind of image that we need to show, the LED is on. It is emitting some of the power. But what happens in OLEDs? You must have heard of OLED televisions, OLED this mobile phone screens. So what happens in OLED is all the individual pixels are off, like it is completely off. No voltage is flowing through it. So it is even more efficient than this LCD. And in LCD, what we use is we use just a backlit. Okay, and the rest of thing is done by the backlit itself, so it does not consume a lot of power. Okay, I hope you understand difference between LED, LCD, and OLED. Okay, even when you are buying TVs, you will see that the OLED TVs are much more costlier compared to LED TV or LCD TVs, because OLED technology, even though it is energy efficient, it is a bit complex. Okay, so okay, here you can see that. Can you see this image here? It is having 2 rows and 16 columns. Okay, that means 2 lines for letters, and we can for each line we can display 16 characters. So in total we can display 32 characters on a LCD display. Okay, so this can be denoted as 16 by 2 LCD display. Okay, this is a form factor for this LCD. We also have 32 by 2 or 32 by 4. Okay, that will be having a larger display, and more characters can be displayed on that particular LCD. But like most of the things can be done through this LCD as well. Okay, so we'll be designing a circuit for this LCD in Tinkercad, and we'll be writing a code just to count the number of seconds. Okay, so I hope you all have joined with your laptops, and like you are able to use Tinkercad, so you can do it parallelly. Uh, so let me show you. Okay, I will hide the code for now. Yeah. See, uh, okay, I need to explain one more thing. This LED has a number of pins. Okay, these are a number of pins. Okay, but what we can do is we can use a I2C module. So instead of connecting all these pins, it will make the circuit more complex. So I can show you one of the circuits that I did with the LED LCD. Just a second. Okay, yeah. The screen is visible, right?
Yes, sir.
Okay. So this is one of my, like, I keep on tinkering with in this Tinkercad environment. Okay. So this is one of my setups that I did, where there are multiple connections. So there are 8 data buses for this LCD screen. Okay. And for each we have to do the connections, and we have to enable the pin. We have to provide a read and write pin. So too much of it is a tedious job. Okay, so what we can do is we can use our I2C, So I2C, what it will do is it will convert these 8-pin data buses to only 4 pins. Okay. So we need only look, basically we need only 2 pins for this, and two are for like power and ground. Okay. So in okay, I have since I have opened this, I will just show you how it works. I will just start simulation. What it does, it shows a table of 5. Okay, it shows table of 5 whenever I press the button. So when I press this button, it will show 5 1 times 5, 5 2 times 10, and in the same manner, it will, like, whenever I press the button, it will just show the next iteration. Okay. And this thing has been programmed in embedded C. This is not done in this Arduino environment. So embedded C is a bit of like on the heavier side, but like I would suggest like use Arduino for this. So just a second. Yeah. Okay then. Okay. So what we will do is we will search for this LCD. So just write there LCD, and what you will be having is LCD 16 by 2 and LCD 16 by 2 I2C. Okay. So what we need to use is we need to use this 16 by 2 I2C. Okay. So just carry it in the working area, and you need an Arduino Uno board. Okay, this is a microcontroller. Okay, always understand Arduino Uno is a microcontroller. Okay, and after that we need to do only 4 connections. So what are the 4 connections? They are ground, VCC, SDA, and SCL. So ground stands for the negative potential pin. The VCC stands for the positive potential pin for 5 volts. SDA is serial data, and SCL is serial clock. Okay, I want you all to just make this circuit on your system. Okay, on your Tinkercad environment. Okay, and ask if if you are having any doubts. I hope you are able to see this circuit here. Do you have any doubts till here? Okay, are you doing? Are you making this circuit? Please respond by unmuting your mic. Are you all like making the circuit? Please respond. Okay, do you have any doubt regarding this? Anyone just respond. Do you have any doubt regarding this? See, the ground is connected to the ground port and the VCC is connected to the 5 volt. Okay. These two are the SDA and SCL ports. Okay. So this is for the data that we will be sending and the clock frequency that will be using to present the data. So after each clock, it has to be refreshed, right? The screen refreshes. So this can be done by using this SCL, SDA and SCL, two pins. Okay. This is the I2C mode of connection. Okay, in the future, if you are working on the hardware itself, you need a I2C module for that. Okay, and that will be soldered to these pins. That will be soldered to these pins, and it will be having just 4 pins that can be used. Okay, you have any doubt? Just tell me. Just unmute yourself and respond. Are you all done with the connections? Anyone just response? Are you all done with the connections? I am explaining it again. This is Arduino Uno microcontroller, and this is LCD 16 by 2 I2C. Okay. There are two types of LCD. One is the normal ordinary one where you need to connect these pins, which is a very heavy task. So you need to use only 4 pins for this using I2C protocol. Okay. So in when you are searching for LCD, just search for LCD 16 by 2 I2C. Okay, I hope you all are done with the connection. So we are having a code here. Okay, yeah. So this is the code. So what this code does is, it will show you a screen where you will be having a count, and it will count the number of seconds. Okay, that's what that's all what it does. Okay, it will be flashing, like for 1 second it will be flashing, for 1 second it will be off. So that's what it will be doing, and it will be counting this number of seconds. Okay. So what we have done is we are using a library for this. We are not going the with the code method, where we will be using this what do you say, hexadecimal formulas and all. We will be just using this library, which is include Adafruit liquid crystal dot h. Okay. After that, we will be defining a variable seconds, which is equals to 0. Okay, because we will be starting with 0 second, 0th second. Okay. Now after that, we will be defining an object. So Adafruit liquid crystal. Okay, this is the keyword that we need to use when defining a LCD object. Okay. So after that, we will be defining LCD underscore 1. So defining this LCD 1 underscore 1, this is the object name, and this will be the object. And we are writing here 0. So 0 explains that it will be like turned off in the initial state. Okay. Now we'll be moving to void setup, where we have to start this what do you say, LCD. Okay, we have to start this object. Okay, so that's why we'll be using LCD underscore 1 dot begin. So begin will start it. So it is a 16 by 2 form factor LCD display. So we'll be using LCD dot begin 16 by 2, 16 comma 2. Okay. And on the starting page, what we will be printing is, when it starts, we'll be printing LCD dot, using LCD dot print to print count. So it will be printing count on the, like, first what you say, row. Okay. We don't want this count to be changed. What we want is, in the below the row, which is the, like, bottom row, we need numbers to be changed when it is counting for the seconds. Okay. So what we will be doing is, now the cursor is here somewhere. Okay, in the first row, we want this cursor to be shifted to the last row. Okay, so for that, we will be setting the cursor. So LCD dot set cursor 0 comma 1. Okay, 0 is the column number. Okay, so and 1 will be the row number. So 0th column, first row, not the 0th row, it will be on the first row. Okay, did you understand? So we are setting the cursor from here to here, this one. After that, we will be set backlight one. We will be using set backlight one function to turn on the backlight. So now the backlight will be on. Then we can see the digits itself. Okay, and it will be on for 500 milliseconds. After that, what we'll be doing is, we'll be turning the backlight off. Okay, and it will be off for 500 milliseconds. So what you will see is, for 500 milliseconds it will be on, then for 500 milliseconds it will be off, and then again this process will repeat, which means that after every 1 second it will turn on and off. Okay. Okay, till here it is clear, I think. After that, what we'll be doing is, it is turning on and off, it is blinking. Okay, but the here this seconds has to be changed, right? So what we'll be doing is we'll be displaying seconds. So this can be done using second plus plus equals to 1. It can also be written as second is equals to seconds plus 1. Okay. Okay, I think I forgot one line basically. Yeah. So this line, the print seconds. So seconds will be printed here in the this line. We have set the cursor here, and it will be printing the seconds here. After that, one blink of the screen, and then again, when the second changes to 2, it will again print the second in this second line, first column. Okay. Do you have any doubts till here? Like, is the this code completely understood by you? Do you have any doubts? Please respond. Unmute your mic and just respond. Okay. Do you have any doubt? Just unmute yourself and respond. Okay. Now let's see what this code does. We'll start the simulation. See. Okay, here you can see that it has printed count, because the first thing, the void setup will be the first function that it has to run. Okay, so it will be printing count on the initialization, and then it will be counting the seconds. Okay, so here what we are doing is we are counting the seconds. Okay, we set the cursor here, and then we are printing the seconds value here. So at first it was 0. From 0 it started, and the blinking, the use of this blinking is just to make it more interactive. Okay, what we can do is just we can okay we can just remove this, and now we can see that the delay, we are having 500-second delay, and then again 500 milliseconds 500 milliseconds delay, and then again 500 milliseconds delay. So it amounts to like 1000 milliseconds, which is 1 second delay. Okay, so now what will happen is, yeah, it will be counting seconds. Okay, so the blinking of the backlight was only this for what you say, for making it more cooler, but What now you can have a continuous on display, which is like counting the seconds. Okay. So do you understand how the LCD works, how we can program it? Okay. Now we can use suppose I would suggest you that try with a temperature sensor. Just a second. Yeah. Use a temperature sensor. You can use TMP36 temperature sensor. Use it with this LED, LCD, and this Arduino Uno, and print the temperature value on this. So on the first line it should print temperature, and on the last line it should print the temperature value. It is a very easy process. You have if you have interfaced the temperature sensor, you can do it like right now also. So but I would give you like a day. Just do it, like complete it, and you can share the screenshot of the this working on the WhatsApp group that we have. Okay, just put your screenshot there, and like we can see uh, how many of you have done actually done this, and how many of you are struggling with this. Okay. Also, if you have any doubt, you can clarify it. That's at the same time. Okay. So what you have to do is just listen carefully. You need to use a temperature sensor. You need to use a Arduino Uno microcontroller. You need to use a LCD display. And with that, what you need to do is use the temperature sensor data and display it on the LCD. On the first line, it should display the temperature, like actual temperature. It should write temperature, and then on the second line, it should display the temperature value. Okay. I hope the assignment for you, like this assignment is like understood by all of you. Today is Thursday. Tomorrow, I think tomorrow is Friday. Okay, so tomorrow, like you are having one day time. You can clearly go through it and try it by yourself, and put the screenshots after tomorrow's session. Okay, in the WhatsApp group. Okay, do you have any doubt regarding this? Did you understand the question clearly? The assignment clearly? Do you have any uh, queries regarding this? Like we'll be marking the name of the students who are submitting these assignments. So please try to complete it on time and submit it in the WhatsApp group itself. Just a screenshot of the actual simulation that will be working, and at that particular time, the whatever will be the temperature and the temperature data. So that the whole circuit screenshot during the working of it should be there. Okay, that's what I want. Okay. So anyone do you have any doubt? Please respond. Do you have any doubt? Like, did you get this experiment completely? Okay, then. Uh, just do the assignment and put your the working like screenshot of the working circuit on the WhatsApp group. Okay, you need to use the temperature sensor. You need to use a LCD and a microcontroller. Program the microcontroller in such a way that you can get the temperature value on the LCD. Okay, at the top you should at the first line you should it should read temperature, and at the second line it should have the temperature reading. Okay, I hope this is clear to all of you. Okay. Okay, fine then. We'll wrap up with this. If you have any queries, just put it in WhatsApp group itself. We'll try to solve it as soon as possible. And see you in the next session. Okay, thank you all. Have a good day.